Video. We are continuing our discussion on the sound waves, and most probably I want this to be the last lecture, and if the problems are not done, all of them, we will try to do all the questions that I have given in the sheet. If not possible, then I will come in the study hour and complete this thing today itself. Okay? I want to start with wave optics from tomorrow onwards. Also, there was a misprint in the syllabus given for the Saturday ko and Monday ko exam hai na. So I think there was a misprint. It was written wave optics. I have not taught you wave optics. That was wave motion. Okay? Wave motion and everything else. Okay? So you already know the theory of all of it. Just start with it. If you are done with first question, then go to the second question and keep going. Don't wait around for me. I am giving you time till 12:02 and then I will start with first question. First question is done. What about second question? Is it done? Go for the second question. This is lecture number 7, na? I did not do it on board. But did I do it myself on board? Then I will do it, don't worry. क्या बोल रहा है? Why is there ये इतना background noise? Do it quietly, the questions. करो शांति से. Question number 1. I will discuss 1 and 2 together. तो पहले 2 के लिए I am giving you time. Then I will discuss. Attempt. Everyone has at least one sheet in one bench. ठीक है. Both sit together. Give me the sheet. I'll give you later. Sit with them. बोलो. क्या हुआ? अच्छा ठीक है. चलो नीचे जाके बोल दो. ओके. ठीक है आराम करो. Is it paining or is it like what? Burning? Eye drops है क्या? Eye drops डालते हो रोज? नहीं, मुझे फीवर है और वो एसी का आगे जाके बैठ जाओ, वहाँ एसी नहीं लगेगी. ठीक है, करो आराम करो. सोचो. Should I start with the question? Let me start with question number 1 And if you are done with question number 2, then listen to it. Otherwise, keep doing it. ठीक है? Second one is 345. 344. 344 is correct. Anybody else with the answer? Should I wait a little more or should I just start? बताओ कोई एक चीज बोलो. I will wait one more minute. It's not that hard.
So what is first overtone, third harmonic?
Closed pipe में क्या होता है? First overtone यानी n equal to 3 होता है ना? बोलो.
Closed pipe का 1, 3, 5, 7 है ना सर. अगर हम फर्स्ट ओवरटोन लेंगे तो 3 होगा.
n equal to 3 होएगा.
हाँ तो फिर
बस यही लेना है और कुछ नहीं.
ये सेकंड हार्मोनिक है ना सर.
अरे बेटे, ऑल द हार्मोनिक्स आर n के ऊपर हार्मोनिक्स होते हैं ना. हाँ तो n इक्वल टू ये कितना है?
3.
तो okay, then I'm starting with the question now. Let's start with the first question itself because I did not do it yesterday. So the first overtone of an open organ pipe beats with the first overtone of a closed organ pipe with a beat frequency of this. So for closed organ pipe, what is the first overtone? That's 3V by 4 LC, na? First overtone, and that's F3 of C. That's 3V by 4 LC. I think this is the first overtone of closed pipe. What about the open pipe? That's V by LO because NV by 2L and N equal to 2. So that will be 2 by 2 and then V by LO. So F2 of open, that's V by LO. And it's given that 3V by 4 LC minus V by LO ka mod minus V by LO ka mod, this is equal to 2.2 hertz. This is given, na? Beat frequency is given. One more thing is given, that fundamental frequency of closed pipe is 110 hertz, and now they are asking to find the lengths. So once you are given the fundamental frequency, what is the fundamental frequency for closed pipe? V by 4L. LC, that's given to be 110. So that means what is LC then? What is LC? That's V. What is the velocity given to be? Velocity of sound? 330 divided by 4 into 110. That will come out to be 0, 0 gaya, 11 ones are 3 by 4, na? That's LC. If I know LC, then can I find 3V by 4 LC? What is 3V by 4 LC? That's equal to 3 into 330 divided by 4 into 3 by 4. I think 330 answer आएगा ना इसका? Then what are the possible frequencies of V by LO? What are the possible values of V by LO? Either it can be 330 minus 2.2 or it can be 330 plus 2.2. Yes or no? So what are the possible values of V by LO? Either V by LO is equal to, बताओ कितना? 332.2 hertz. And then what is LO? That's 332.2 divided by 330 meters. Either this value or V by LO is just the subtraction of 2.2, and that you will get to be 327.8, na? And that means what is LO? 320, बताओ 330 divided by 327.8 meters. Is it okay? These are the values that I am getting of LC and possible values of LO. Is there any problem with this? This is question number 1. I think I gave you this yesterday as well. So this is OR. Now let's come back to the question number 2 that I gave you just now.
Shouldn't that L1 be the equilibrium is 330 by 332, right?
330 by 330. I made a mistake here. Should be 330 divided by 332.2. Is it correct now? It's okay? And that is 327.8. ठीक है? Anyways, now question number 2. What is the question number 2 asking? You have a vibrating string of some tension and some length. It resonates with a mode corresponding to first overtone of an air column. What do you mean by resonates? It means that the frequencies are equal. So you have a string का setup. इसकी कोई frequency है that resonates with what? With a closed pipe ना? That's closed pipe. और closed pipe का क्या है? First overtone. That's 3V by 4L. So whatever is the frequency here, and what is the frequency given to be? 1 by 2L root T by mu. Then some frequency of this is equal to this. This is given in the question. ठीक है? Initially. The string also generates, so you have a situation of organ pipe and string. Now they are comparing a string with a fork. ठीक है? The string also generates 4 beats per second with a tuning fork. अब एक tuning fork ले लो of frequency n, it beats with it. ठीक है? What do you mean by? अच्छा, तो that means 3V by 4L minus n is equal to 4. This is given in the question, na? Yes or no? This is given. And then they say when the tension is increased, tension increase होएगा तो बोलो ये value increase होएगी कि नहीं? Yes, they are both same. Tension increases. That means this frequency increases. Let's call it F1 for the argument F1. अब if the tension increases, F1 increases, but in the question it's mentioned that the overall beat frequency decreases. When can that be true? When n is less than F1 या फिर n is greater than F1?
No, greater than.
सोच के बोलो. I have this value of F1. This increases as tension increases, but they have given that this overall thing decreases. So that means which should be greater? N should be greater than F1, na? This should be the value of 4, because it makes sense then. If this increases, then this subtraction decreases. So that means what is the equation? N minus this thing should be equal to 4. That is my equation. N minus 3V by 4L should be equal to 4. Yes? And now they are asking to find N, na? They are asking to find N? Yes. So now I can find the N very easily. I think the length and everything is given. Then can you tell me the answer? It's something like N is equal to 3V. What is the velocity of the sound given to be?
340.
340, and the length?
75.
Centimeter. So 4 into 0.75. This will reduce to 0.25, and 0.25 into 4 is what? That's 1. So answer is 340, but then there is an addition of 4. है ना? ये उधर गया फिर plus 4. So the answer is 344. Are you understanding how I wrote this equation? Why didn't I write 3V by 4L minus N? That's very important to understand. पक्का समझा? वापस बताओ फिर से? समझा ना? Attempt question number 3. This is even, let me give you the options of question number 3. Options are these are the options. Now attempt the question. So please write these options in your page. This is the time at which you come. क्या? जाओ, सो जाओ. Akshay, you sit here. Try to at least read the question. That will give you some kind of understanding what they are asking. I don't know. You go through all the options. If you find it to be correct, then tell me. A and C. That's incorrect. Very good. Attempt. Keep attempting. A and D. A and C. Both of you are incorrect. Only A incorrect. B and C. Are you sure with that? बस तुक्का मार रहे हैं. अच्छा.
Sir, if like one is increasing, one should decrease so that the overall mean frequency.
They are not decreasing at the same time. You are taking separate possibilities. Only C, that's incorrect. Which is the perfect combination of answers? They are not decrease at the same time. Only one of them either increases or one of them either decreases.
And then it remains the same, so the difference of the frequencies should be the same. So
Yes.
both of them should increase, right? So both of them should
Not
increase.
necessarily. Not necessarily. Sorry. Should I start with it then? 1 more minute. B and C. Are they occurring at the same time?
Because if one decreases, then it will become same as the first one, and we have 6 again. 6 bits again. But if we increase T2, then like T1 is already increased, so the both will be equal and we will have 6.
No, you are increasing, decreasing at the same time again, I think.
So like for example, there are 3 cases. In first case, the idea the given is 6.
Don't talk!
If we decrease T1 slightly, and if we increase T2, in 2 different cases, both the result will be same. Like
Acha.
we have to assume that.
Can you give me some examples and by that can you show?
Here T1 is already higher here.
Huh?
If we decrease it, it will become like same as T2, so it will become 6 again. Like that first case. But if we increase T2, so it will become like T1's higher value. So it will become 6 again.
Yes. Could be said like that.
If we increase this slightly, say 1, it becomes 7 answer. If we decrease this, now this is kept constant. Now if we decrease this, the answer is 7 again. So this and this.
A and C.
B and C.
But okay. So but your final answer is 7. But it should be unchanged, I think, in the question.
So let it be, but slightly maybe.
C, D, incorrect. BC. Show me the reasoning.
They said that T1 is the tension with that is more having more tension, and T2 is having less tension. So if we increase the lower tension by a little bit, it will be unchanged.
How?
Because T1 is having greater tension than T2.
Yes.
If we increase T2 by a little bit, the value will not be that changed.
Okay.
And then if we do the same with T1, like separately, then it still won't be unchanged because we are decreasing it by a small value.
There's holes in your reasoning, but ठीक है. Let me explain it. किसी से मांग लो बेटा. ये है ना इसके पास, तीनों साथ में आके बैठ जाओ. BC मैं बता रहा हूँ, अब बोर्ड पे एक्सप्लेन करता हूँ. What is asked in the question? You have two wires with tensions T1 and T2 given. Yes? Don't talk now. Now I am explaining. You have two wires. One of them has a tension T1, other has a tension T2. It's already given that T1 is greater than T2. Okay? And if the tensions are greater, then your frequency in a stretched string depends on the root of tension, na? Square root of V equal to root T by mu, F is proportional to root T. So that means if tension is increased, then the frequency is increased. So the initially already the frequency F1 is greater than F2, and it's given that F1 minus F2 is 6. This is given to me. Okay? Just for example, let me take some values so that it is clear. For example, 346 minus 340 is equal to 6. For example, okay? Now understand the scenario. If I separately increase the tension of T1 only, if I increase the tension of T1, the F1 will increase. F1 increases, even if you increase slightly, the difference between them, will it ever remain 6? You can go 347, 348, 1000, 10,000, will it ever be 6 again? There is no possibility that it will become 6 again. So tension T1, if you increase separately, the beat frequency will change surely. Okay? But what if you decrease the T1? If you decrease the T1, and let's take the mod here. If I take the mod here, then there is a possibility that if you decrease the tension T1, the frequency decreases and becomes 334. And if you have 334 minus 340, that will again come out to be 6. So if you increase the tension T1, there is no possibility that the beat frequency is again 6. But if you decrease it, there is a possibility that it will become 6 again. So what should you do? You should decrease T1. Let's look at the other scenario. What if I decrease T2? If I decrease T2, then there is no possibility that the difference becomes 6 again. Yes or no? It will always be a little more than 6. But what if I increase T2? Maybe this becomes 352. It becomes 352, then there is a possibility it becomes 6 again. There is only one possibility in which it can become, but there is a possibility, right? So what should be the correct answer? That either you can decrease T1 or you can increase T2, and in both of the cases there is a possibility that the beat frequency remains 6. Do you understand? If you increase T1, you will never get 6 again. If you decrease T2, you will never get 6 again. So wahi hai. This is the answer. So B and C, I think. Yes? Good. Attempt question number 4. You're not simultaneously increasing, decreasing. While making the above changes in tension, हाँ ठीक है, but it is separate. नहीं, कैसे A और D होएगा? अभी तो बताया A और D हो ही नहीं सकता. Question number 4, attempt. बोलो. हाँ, तब तो वो हो सकता है पॉसिबिलिटी. अगर दोनों को साथ में इंक्रीज किया, साथ में डिक्रीज किया, तब तो सब ही पॉसिबिलिटीज है. फिर तो तुम्हें क्या रहना चाहिए पता है? ऑप्शंस में ऐसा रहना चाहिए, T1 इंक्रीजिंग कॉमा T2 इंक्रीजिंग, T1 इंक्रीजिंग कॉमा T2 डिक्रीजिंग. ऐसे कॉमा दे के एक साथ रहना चाहिए ना. फिर तो ये सेपरेट ऑप्शन ही दिए हुए. Yes, any answers for question number 4? I am waiting 3 minutes, then I will start. Answer decimal, you can give it in decimal. ये 0.25 इसका पार्ट नहीं है, ये सोल्यूशन का. मैं 0.25 पिछले सोल्यूशन का कटिंग है ये. षणमुख, इसे मैं 0.25 भी लिख दिया. ये इसका पार्ट नहीं था ये क्वेश्चन का, समझा क्या? हाँ हाँ, षणमुख ही है ना हम तुम्हारा? हाँ ठीक है.
Approximately 0.75
किलोमीटर पर आवर, हर्ट्स.
Sorry, meters per second.
नहीं, हर्ट्स बोल रहा था.
Meters per second.
Idiot.
0.75.
0.75 is correct. Go for question number 5. If you are done with the fourth one. Should I start? I'm waiting 1 more minute. हाँ भूवित, आंसर नहीं आ रहा आज. Any one of you got 4th? चलो चलो कैलकुलेशन करो जल्दी. हाँ, उसका मुझे एक बहुत अच्छा डिस्कशन करना उस पर, इसलिए मैंने वापस क्वेश्चन डाला. 5th वाला. हाँ,
वो अच्छा क्वेश्चन है.
क्या है?
B या C, उसको छोड़ के और दो करो.
हाँ, B और C करो, कोई ना.
5 का है 970.
जाओ लास्ट, ये जाओ 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 जाओ, चेंज करो जल्दी जल्दी. Disturb my class one more time and I'll change your sections.
Fee is approximately
1032. हाँ चल जाएगा. Should I start? Chalo, I'm starting with question number 4. Let's understand the question. You have a sonometer wire. Don't worry about the sonometer, it's just a wire. Under a tension, beating in its fundamental mode. 0.75. For the question number 4, na? That's correct. You have a wire under tension beating in its fundamental mode. Fundamental mode यानी कि V by 2L under root T by mu ना, 1 by 2L under root T by mu. That is the fundamental mode ना. The vibrating portion of the sonometer wire has this length, mass इतना, ठीक है. The vibrating tuning fork is now moved away from the vibrating wire with this constant speed. And now what will be the beat? No, beat is given, you have to find the speed. So what is the situation like? You have a sonometer wire or maybe some kind of wire, and what is the frequency here? F1. This is the frequency with which it vibrates. Initially you have a tuning fork which resonates with this frequency, and now what happens is you put this tuning fork away. This tuning fork is moving away. It's moving away with the velocity Vt, and obviously as it moves away there will be Doppler effect, and due to Doppler effect there is a change in frequency. They have given that there is a person here standing, he hears some frequency from here, and he calculates that the beat frequency is 1, and now you have to find the velocity with which the tuning fork is moving, right? What is the frequencies that the guy will hear? There will be this frequency that he hears, and the frequency, so a source is moving opposite to you. What is the formula of Doppler then? Batao. V by into F. This is the formula, na? This is the frequency that he will hear from this, and this is the frequency that he will hear from this. Yes? So, and what is this F? That's F1, because initially they were in resonance, na? Initially they were in resonance. Which of them will be greater, by the way, this guy or this? This one will be greater because this factor is less than 1. So what is the beat frequency ka equation then? I shall find the F1 first. What is F1? 1 by 2L root T by mu. तो बताओ values जरा. तो mu can be written as mass per unit length, and I think this will simplify to 1 by 2 T by ml. Is it correct? Please check. And now what is the tension given to be? What is the mass? ये -1 है ना length, and that will be 64 into 10 power 4. Take the root of it, 8 into 10 power 2, and then divide by 2. So that will be 400 hertz. This is F1. What is the F apparent that you have here? बताओ F apparent कितना होएगा? That will be V over V plus Vt. That's the velocity of the tuning fork into F1. and the equation given is f1 minus f apparent is equal to 1. This is the beat frequency, na? And now you just plug in every values and then you'll get the answer. So what is f1? 400 minus, what is velocity of sound given to me? 300 एंड बताओ इसका आंसर कितना आ रहा है? ये 399 और rather let it be no, that will be 399 400 300 divided by 300 plus Vt, and then you do the calculation, and I think what do you get Vt to be? 0.75. So I'm leaving the calculation to you approximately. This is the value that you get. Do you understand the question? Initially they were in resonance. Now the tuning fork is moved away. Then you hear some beats. You will always hear a beat when, or there will be beats only if there are two sources of sound. This is the question. So if you have understood question number 4 and if you have written it, go for question number 5. Question number 5 is sort of a repeat, but there's a discussion that I want to do in B part.
970, 1032 and 62.
Approximately, yes. क्या चीज़?
330 is the first one.
In the question number?
Fifth one important.
It should be 330, I think. Assume it to be 330 and then do the question. जो सिक्स्थ वाले का? अच्छा. वेट फॉर 6th one. पहले 5th वाला डिस्कस कर लो, फिर 6 करेंगे. Let me give you some time for the 5th one, and if you're done with it, then tell me. So 1239 पे 5th वाला करते हैं.
B.
1060 is incorrect. That's 1032 is approximately correct. Hmm, 0.7. Anybody else with the answers? 103? 103. That's incorrect.
1031.
हाँ, तो ठीक है.
1031.
That's exact.
The previous range that we have written, one numerical answer was like 0.5. 0.5 was the answer. If it is 0.5, so we could approximate it to 1. What if it is 2.5 or 3.5? If it is 2.5, it should be.
ऐसे तो क्वेश्चन ज़्यादातर नहीं देने चाहिए. You should have a question where you should get exact value. ऐसे points में, decimals में नहीं. But if your value is less than 0.5, approximate to the lower bound. If it is greater than 0.
2.5 we are getting. 3 or 2.
ये नहीं आना चाहिए.
The answer is only 0.5 in that question.
अच्छा
The exact answer is 0.5.
हाँ, but the answer given in that answer key
One.
1
I mark it as 0.
किस में, फिजिक्स में? देखता हूँ मैं, देखता हूँ बाद में. Should I start with question number 5? I will wait 1 more minute and then I will start.
The 7th question is multi-current.
No idea.
Are sir?
Whatever you find correct, then take it. Khatam.
No, I have to solve all the 4 right for that.
Either way, you have to solve all 4. Okay, I'm starting with question number 5. And what is the question given to be? A siren emitting a sound of frequency this moves away from you towards a cliff at a speed of 10 meter per second. ठीक है? So there's an observer from which this source of sound is moving away. Then what is in the A part they are asking what is the frequency heard directly from the source. Na? So that will act like a source going away from you. What is the frequency heard? V over V plus Vs, ऐसा क्या है ना? Then what should be the for A? F1 is equal to V over V plus Vs into F, and now just substitute and get the answer. What is V given to be? 330, and then into 1000, and what is the answer you are getting? 970.6 है, I think ऐसा कुछ तो. This is F1, the frequency heard directly from the source. Yes. Now let's look at. There will be a reflection from the source, right? A reflection from the wall. A reflection from the wall, and how it comes to ऐसा देखो. Whatever is the, now look at this, this is the reflection from the wall and this is what you will hear. That's a sound wave. We say that Doppler effect only occurs when there is a motion between either of the source or the observer. Na? Only then Doppler effect should occur. This wall, from this the sound wave is getting reflected back. Then it acts like basically like a source. ठीक है? From this source, is the source moving? Is the observer moving? Should you find a Doppler effect here? Then why did you find a different frequency than 1000?
Sir, because this time it is going away from the observer.
Who is going away?
The sound wave is going away from the observer, and at the second case it is coming towards the.
So, yes, sound wave may be moving, doesn't matter. Doppler effect matters or it only takes into form when there is a source ka motion or the observer ka motion.
That frequency will depend on the source because as it moves closer to the mountain will experience the Doppler effect from the source.
Yes, that is the key to this. You may think maybe the wall is not moving, then how is there a Doppler effect? The wall will reflect that frequency which is incident upon it. And what is the frequency incident upon it? This is the frequency incident, na? And in that case, the wall is just a observer and the source is a source, actual source, from which a frequency is coming and it is just hitting it back. And what is the frequency which it will hear? The source is coming towards that person. It should be minus sign in the denominator, na? Are you understanding the whole thing? This source will give off one frequency which will be V over V minus Vs, and that is the same frequency reflected back. So it's not that the source is not moving here or the wall is not moving here, so you will not find Doppler. It's from this the Doppler is reverting back. Hai na? So what is the frequency heard by the person? For part B, F2. That will be V over V minus Vs into F. So that's very important. Ki I made a statement actually last time, slightly incorrect, and I also wrote in the description in the lecture 7 that I made a slightly wrong statement. The statement that I made was ki Doppler effect is an observer dependent phenomena, and whatever F apparent that I have written is just what the person hears and is not the actual sound ka frequency. That's only partially correct. Doppler effect is an observer dependent phenomena. It depends on the motion of the observer. That is true. And the F apparent that we have written for the motion of the observer, that is the frequency heard by the observer. That is not the actual frequency of sound. The actual frequency of sound is F. But whatever F apparent that we have written is what is the person hearing it. That's not the actual frequency. But as soon as the source starts moving, now there is actual change in frequency of sound. It's not that the F apparent is what we are hearing. It's not that. There is actually change in the sound ka whole thing. Are you understanding? So this thing, whatever I am written, it's not like ki this F apparent is only dependent on motion of the observer. No. Are you understanding this point? This is very important, very crucial.
The source is moving, the F apparent will be also changing.
That's why the F changes to F apparent. F changes to F is the original frequency, it changes to F apparent. Are you understanding? And in the third part, you find beats, but beats can only be formed by two waves. There are two waves. एक ये wave जो original sound से आ रही है, और एक ये wave जो reflect होके आ रही है. And what is the beat frequency out of them then? What is the answer here? And this will be F2 minus F1. That's approximately 61.7 Hertz, I think, or maybe something. check करना. ठीक है? Approximately 62 लिख देता हूँ ताकि बच जाऊँ. ठीक है? Anyways, so this was question number 5. Is there any problem in it? The idea is clear of Doppler effect. ठीक है. Attempt question number 6 and I am giving you the diagram of it. तो these are my observers. This is moving with some Vs. ठीक है? And now attempt the question. देखो, I know you won't be able to make the exact diagram as me, but please attempt. It's a piece of art. They are basically on the same level. वो मैंने ऊपर नीचे थोड़ा बना दिया, but they are basically on the same level. ये तीन में से कौन क्या है बताओ? वो थर्ड ऑप्शन ओके, ये O1 है। ऐसा है तो फिर मैं सबका ही वो कर दूँ, कोई प्रॉब्लम नहीं है।
सर वो दूसरा वाला सीन है ना,
हाँ, ये बाल उठे हैं बेटा, एंटीना जैसे। इज इट फेयर नाउ विरूपागा? यस, एवरीवन हैज हेयर। हाँ,
Frequency as it is approaching or after it gets reflected.
आई डोंट नो, आई एम अ बायोलॉजी टीचर बेटा, आई डोंट नो दिस फ्रीक्वेंसी है, ये सब चीज़ें। यू अटेम्प्ट द क्वेश्चन, यू टेल मी। अरे 6 करो, 6 दिया है अभी। सोचो सोचो, सब आएगा। यहाँ पे एक वेलोसिटी है बी में, ऑप्शन ऑब्जर्वर 2 में। That observer 2 is moving, it's some velocity vs. So don't forget that.
That Vs and the Vs are same.
क्या बोला?
That Vs and the Vs given in the question, the speed of sound is same.
दोनों सेकंड बेंच वाले दोनों लास्ट बेंच पे जाओ। चलो, अलग अलग लास्ट बेंच पे, एक साथ नहीं बैठना है, हाथ पकड़ के एक दूसरे को। बोलो। Observer 3 is 0. Are you sure with that? That's correct. Very good. Two. हाँ, जाओ जाओ। तीनों अलग अलग बैठो, एक कोई तो एक नीचे बैठेगा, चूज करो कौन सा। हाँ ठीक है, बैठ जाओ नीचे। नो यू कांट, आगे आगे बैठो। कोई नीचे बैठेगा तीन में से। नो बोलो। नहीं, एक गया है ना अभी, मुझे क्या पता कौन गया, मैं बस हाँ बोल देता हूँ, मैं देखता नहीं कि कौन गया कौन नहीं गया। ये फर्स्ट बेंच वाला क्या नाम है इसका? श्रीनिवास। हाँ भरत, आंसर नहीं आ रहा आज। At least write name at the top of the sheet. What if it gets displaced?
Sir, they are looking like pulleys.
They're looking like pulley. How?
That is the.
You're imagining very wrong way. It's not a pulley. It's a full-fledged person, almost like a 99% human being. Has eyes, nose, and everything. What more do you want?
Sir, this guy wants a sheet, sir.
What? You don't have a sheet? It's okay. Sometimes you don't get things.
Life is unfair.
Yes. क्या लिखा है इडियट?
ये मैंने नहीं लिखा सर, सर इसने लिखा सर, मैंने नहीं लिखा।
सो इसका सर करो। चलो तुम उसका करो।
हाँ सर, इसने भी लिखी सर।
करो करो।
It's not my handwriting, sir.
V into Vs over, don't talk. V into Vs, oh आ जाओ, मैं चेक कर रहा हूँ. ऑब्जर्वर 1 का बोल रहा ना. ऑब्जर्वर 1 V into Vs
divided by V plus Vs into V minus Vs.
A minus B, A plus B, A square minus B square, बस और कुछ भी नहीं है. इनकरेक्ट. No, it's unitless what he is saying. No, there's another mistake actually. There's a factor of 2 he's missing. Incorrect.
Minus 2 maybe.
माइनस फ्रीक्वेंसी नेगेटिव बन गया.
Like mod B.
तो क्या बोलना चाहता है?
2V into S by V plus Vs.
दैट्स बस उतना ही ना. इनकरेक्ट. अरे इडियट है वो, छोड़ो. F का फैक्टर ही भूल रहे कहीं ना कहीं. So I'm starting with this question number 6 now. Let's understand what is happening. ये source of sound है, ठीक है, और उसी के ऊपर O2 बैठा हुआ है. Okay. Now let's understand what is happening. This source of sound will give sound in all possible directions. So for let's understand for O1 what is happening. यहाँ से एक sound आ रहा है ना, where it looks to me as if the source is moving away from the O1. That means what is the frequency heard by this guy? V over V plus Vs into F ना. This is the frequency heard. There will be, अच्छा beats कब होंगे? जब there are 2 waves. Where will the second wave come from? ये एक sound जाएगा, hit करेगा wall को और उसके बाद वापस आएगा. Yes or no? So for the wall, what is the frequency which is hitting it? That's V minus Vs na? Are you understanding this frequency? This is V over V minus Vs into F. And that is the same frequency which is reflected back. Are you understanding? For the wall, the source is going towards it. When it is going towards it, then this is the formula na? And that is the same frequency which is reflected back. So for the O1, these are the 2 frequencies which he will hear, and the beat frequency will be what? So for O1, which of them is greater, by the way? This guy. This thing is greater. Then what is FB? That's V over V minus Vs into F minus V over V plus Vs into F. There's a factor of F there. And then you take the LCM and everything, and what will you get? बताओ इसका आंसर कितना आ रहा है? यस. This is the beat frequency that F1 will hear or the observer 1 will hear. What about observer 3? Now let's understand for observer 3. अब इधर क्या हो रहा है? Tell me that. For observer 3, the source is moving towards it, na? That will be one frequency. And what is the reflected frequency? The same thing. So what will be the beat frequency then? 0. So F beat is equal to V over V minus Vs into F minus V over V minus Vs into F. Are you understanding how I have written this thing? Yes? Understanding? Then this is 0. What about O2 now? This is very interesting. Tell me for O2 what will it be? So O2, first of all, it is hearing the sound just directly from the source. Na? Because it is sitting on the source. If it is sitting on the source, so it hears one frequency, that's f. No change in it. There is no relative motion, no change in it, f. What is the other frequency that he will hear? The reflected one. But now there will be some changes in the reflected one. Why? Because previously when I was writing O1 and O3 के लिए reflected one, O1 and O3 were not moving. Here the observer itself is moving. Yes or no? When the observer also moves, then what is the factor? You have, अरे formula क्या था? V plus or minus Vm plus or minus Vo ऐसा होता था ना? So if the observer is moving, there is some factor in the numerator. अब understand this. Sound wave reflect होके ऐसे आएगा और observer भी उसी की तरफ जा रहा है. तो फिर क्या होना चाहिए? Plus या minus? Plus. So there will be a beat frequency V plus Vs over V minus Vs into F minus F. Are you understanding? This is the sound because you are sitting on the source. This is the sound which is reflected. It's a little different than the others. So what is the answer you get here? ये थोड़ा calculation करेंगे तो 2 VSF over V minus Vs ना? This is what you are hearing. The beat frequency to be. So here FB equal to 0. Let me write it a little better. So either 2 VVS F either FB equal to 0 and either 2 VSF V minus Vs. So it's not that hard. Not that hard. Do you understand? This is question number 6. Attempt question number 7 then. If you are done with this, attempt question number 7. A and B is incorrect. A is also incorrect. AC is also incorrect. Tell me the correct combination. So,
Should we select correct or incorrect?
huh?
Correct option or incorrect option?
I am telling you the combination is incorrect.
No, we have to select what, correct or incorrect option?
Correct options obviously.
I'm getting this one.
Which of the options are correct? जाओ जाओ. Are you better now?
Sir, A, B, C.
A, B, C.
A, B, C.
D नहीं?
D, 2 factor is missing. 2 V.
Correct. A, B, C is the correct combination. Anybody else with the answer? Acha, for those who didn't get the sheet, come after the lecture in staff room. I will give you. ABC is correct. Jao, jao. Should I start with 7th one? ठीक है, I will wait 2 more minutes. Akshay, come and sit here. C is the speed of sound, not the observer. V is the speed of the wall, I think. Don't go for 8, 9, 10th. If you are done with 7th, don't go for 8, 9, 10th. Attempt 11th and 12th. No, not the correct combination. Okay, I'm starting with question number 7. A and B, that's also incorrect combination. Let's understand the question. I'm trying to explain now, तो ये background noise मत करना. ठीक है? You have a source of sound with some frequency travels horizontally to the right. It is reflected from a large vertical plane. There is a wall which is moving towards the left with a velocity v. तो ये sound ऐसे आ रहा है with some velocity c, and there is a wall which is moving velocity v. ठीक है? Now they are asking a bunch of things. What is the number of waves striking the surface per second? Number of waves striking per second, you can imagine this to be an observer, na? Imagine it to be an observer with velocity v. Then what is the frequency heard by the observer? Is the number of waves hitting the wall? Yes or no? Number of waves striking the surface is just as if what is the number of waves or the frequency heard by the observer? The moving observer. And the observer is moving towards the sound. Then what should be the equation? For option A, what is the frequency then? Batao. That's V plus VO divided by V into F. But V is the speed of sound. That's C plus V divided by C into F. Sound is also what? There is no source, there is only sound. There is only sound waves which are coming from left to right. You are not given that it is on an ambulance car or in something and that is moving.
So we consider it to be stationary.
There is some source, some speaker from which this sound waves came here. We don't care about that. There are sound waves here, that's what we care about, with some frequency f. Bas, और कुछ भी नहीं, ठीक है? What is the B part? The frequency of the reflected wave. अब reflected wave, what will that frequency be? So obviously all these frequencies that I am writing, they are heard by an observer, na? Let's assume there is a stationary observer here and he is listening to a frequency which is reflected from the wall. Now the wall will act like a source. the wall will act like a source, gives off some frequency, and the source is moving towards the observer. Then what is the formula for it? For option C, I think it should be F2 will be V by V minus Vs into what frequency? F या F1? F1, because F1 is the frequency that is the वो ले रहा है ना, और उसके बाद रिफ्लेक्ट हो कि ये आ रही है F2, तो F1 इधर आएगा. तो फिर क्या होना चाहिए? फिर बताओ, V by V minus Vs कितना होता है? C over C minus V into C plus V over C into F1, and then what do you get? F2 to be C plus V over C minus V into F. This is F2. And then for option B, I think you have to find the wavelength. तो wavelength क्या होता है? Speed equal to V equal to F lambda, then lambda equal to V by F, right? Lambda is equal to V by F, then what is lambda to? C by F2, and that will be C minus V over F into C plus V. Yes. No, ऑप्शन बी में ना, नहीं ऑप्शन बी में ज़रा वो फ्रीक्वेंसी को कट करके वेवलेंथ लिखो ज़रा. वो मेरा थोड़ा मिस्टेक हो गया था. अच्छा श्रीराम, मैं ए बी सी तीनों बोला ना? तीनों दो फ्रीक्वेंसी अलग अलग बोल रहा है, कुछ भी बोलता है. नहीं, बी में ज़रा मिसप्रिंट है. बी में मिसप्रिंट है, फ्रीक्वेंसी नहीं है, वेवलेंथ है. आई फॉरगॉट टू टेल यू दैट. ठीक है, ठीक है. इट वॉज नॉट इवन ए एंड बी, देन इट्स ए एंड सी. एनीवेज, what about the D part? D is the number of beats heard by a stationary listener to the left. तो ये stationary listener जो है ये इधर, what are the sound waves that he is listening? A sound coming from left and a reflected wave coming from right. So what is the FB? That's C plus V over C minus V into F minus F na? And then you do this calculation, what are you getting? 2Vf over C minus V, I think. Please check. And I think in the option D there is a factor of 2 missing. So options A, B, C are correct. Options A, B, C are correct. And please make the changes ki in option B that's not frequency, that's wavelength. Okay? ठीक. If you are done with 7, go for 11th. अरे उसका डायग्राम बहुत खतरनाक है, अभी मैं बना रहा हूँ, रुको. Hey, listen to this. Everyone see this diagram, otherwise you will lose it. See step by step, ठीक है? There's a source and an observer. Everyone with me till now? There's a Vs and there are dotted lines. This is a diagram. Now attempt. बोलो, कोई बात नहीं, अटेम्प्ट. अरे खतरनाक. अरे इसको पॉज करो, तब तक पॉज नहीं कर सकते क्या?